How's it going, everyone? Today we're going to learn the concept of currying in Python. It's not something you'll see being used every day, but it's definitely interesting and worth learning about. In today's video, we'll be using the Z code editor. If you want to code in Z as well, I've left a link in the description box down below where you can download it for free. Anyway, let's cover currying. What exactly is currying in a programming context? Well, currying is a functional programming technique which turns a function with multiple arguments into a sequence of functions. Each function in the sequence takes only one argument, and this technique is quite useful for creating flexible functions. Let's take a look at an example of currying. For this example, we will use the callable type, which is a type annotation. If you enjoy the benefits of type safety in Python, I recommend importing this. Otherwise, you can ignore it. Next, we're going to define a function called multiply, which will take only one argument. And then it's going to return a callable. And the callable is going to be a function which takes an integer and returns an integer. Then inside, we're going to create another function, or a nested function, called multiply. And this function takes another integer and returns an integer. So now we have the callable that takes an integer and returns an integer. So all we have to do here is return multiply, and that will be our curried function. Next, to use it, we can create a variable called double, insert the multiply setup function, and include the setup. So for double, we're going to insert 2 because we want to be able to double any number. Otherwise, we can triple any number by typing triple and inserting the multiply setup with 3. Then we can print the double of 10 or the triple of 10. And when we run this, what we will get as an output is 20 and 30. So these effectively doubled and tripled the number. And this entire process makes it very easy to create new functions using different setups without having to define them entirely from scratch. Now, there's another way we can achieve this, and I'd argue that this approach is far more readable. It's important to note that this approach is not the same as currying, although it can achieve the same result in certain contexts. So, while currying can be done with a few lines of logic, I'd absolutely recommend using the easier approach provided by functools, especially if your function doesn't rely on a step-by-step setup. For this example, we're going to import partial from functools. Then instead of creating a curried function, we can just use a regular function, which is far more readable. With that function, we can create a partial function, which only requires the function name and the arguments we want to supply. So here we created double and triple, then we used the partial function and provided multiply. And as the first argument, we added 2 and 3. So this is going to use 2 and 3 as the default for A, when we call double and triple. It's important to note that we are not limited to passing in only one argument here. If we had a function that took many arguments, we'd be able to pass in as many as we like in this partial function. Now when we try to call this, the rest is going to be the same. So double of 10 and the triple of 10 will be 20 and 30. Another thing that's nice about partials is that you can choose to pass in keyword arguments in case you want to pass in arguments in a different order. As you can see here, we have a function called greet that takes a name and a greeting. And maybe we want to create a function that uses a different greeting. Well, to do that using a partial, we would pass in the function and then the keyword argument. So for greeting, we want to insert yo. And for the second one, we want to insert hola. Now we can just type yo, Bob, or hola, Bob. And when we run this, it's going to use both of those greetings. So if the sequence doesn't matter, you can easily use partials to avoid over-engineering your code. But let's take a look at one more example that uses currying. This time, we're going to create 2 nested functions, which in my opinion already becomes very hard to read. So for this example, we're going to import callable once again. And since I'm big on type safety, I'm going to create a couple of types. And this is using the new Python 3.12 syntax. So here we can just type in type and pass in the type, which will be a callable that takes a float and returns a float. Then we're going to create another type called discount factory, which is a callable that takes a float and returns a final price. And again, if you don't like type annotations or don't want to use types, you can easily ignore all of this. But next, let's create the first function in our query, which will take a tax rate for a product. So here we have a function called apply VAT, and the tax rate will be the float that we provide. And that's going to return to us a discount factory, which is this callable over here. Then inside, we're going to create a function called apply discount, which takes a discount amount and returns a final price. And finally, we're going to provide a function called calculate final, which takes a float and returns a float. And here we're going to return the final price, which will be the price minus the discount amount times the tax rate. Then for each one of these, we need to return the appropriate function. So here we need to return calculate final, and outside we need to return apply discount. And for some reason, I imported API version. And finally, let's test our function. So let's get started by creating a discount factory. So here we call apply VAT. The tax is going to be set to 25%. Then below that, we're going to create two discounts. One that applies a Black Friday discount and one that applies a Christmas discount. The first one will be a $300 discount and the second one will be a $150 discount. And finally, let's create a product to discount. So here we're going to have a fridge, which will be set to $500. We can print that the fridge is $500 and that the price for the fridge on Black Friday will be this price over here, which applies the Black Friday discount. And we will do the same thing for the Christmas price. And now when we run this, what we should see is the original price of the fridge, the Black Friday price, and the Christmas price. And while it might seem like a bit of setup, we just created a function that can be used in many different ways. Unlike with regular functions or partials, here we are required to do things step by step. The order matters. So we always have to apply VAT before we apply a discount, before we calculate the final. We can't do this in any other order. Now the downside is definitely readability. Take one glance at my queried function and you'll feel like a career in cleaning toilets at McDonald's doesn't seem so bad after all. But with proper naming and documentation, your queried functions can definitely make your code much more flexible. And I just want to mention that as a day-to-day programmer, I rarely use querying, but I find it to be an interesting concept nonetheless. And as I've mentioned many times before, the best thing you can do as a programmer is learn about all the options, and then pick the best one for the job. You might decide to opt in for a class, which is much more readable and easier to create. But querying remains a great concept nonetheless, and you can use it in pretty much any programming language. So it's not just a Python-specific concept. Anyway, I would love to hear your thoughts on querying in the comment section down below. But otherwise, with all that being said, thanks for watching, and I'll see you in the next video.